So in part 2 and example 4, we continue our work with the compound in the continuous interest formulas. So example 4 is wanting to know how many years will it take for an initial investment of 10,000 to grow to 25,000. Assume a rate of 6% compounded continuously. So again, continuously is telling me which of my two formulas to use. So I know I need to use A equals PE to the RT. And in this case, they're telling me that we have an initial investment of 10,000 and we need it to grow to 25,000. And we have an interest rate of 6%, so that's 0.06. What's missing this time is the time. So now we have to go solve for a variable up there in the exponent position, which is why this stuff falls into this chapter. Well, let's plug in our numbers. So we know that we need 25,000 at the end of time. We're starting off with 10,000 at the beginning of time. E to the 0.06 times t, and we need to go solve for t. So in order to solve for t, it's important that you do the correct order of operations. It is much easier to divide this 10,000 out first than to take the log of a product. So we're going to go ahead and divide the 10,000 out as the first step. Always isolate the base that has the exponent. So we're dividing by 10,000, not the e. You can't divide out the e, just the 10,000. Okay, now if this divides nicely, meaning a terminating decimal, go ahead and divide it out, just work with the decimal. But if it does not divide nicely, you need to make sure you carry it as a fraction until you hit the calculator portion at the end. This one divides, so we'll use 2.5. It terminates, it's a nice decimal. That's equal to e to the 0.06t. But if this were like 1.3333333, I wouldn't do that. I would use the 4/3. So, okay, now the only way we have of bringing the t down out of the exponent spot is by taking the log of both sides. And because we're dealing with e, we'll do an ln. So the natural log of 2.5 is equal to the natural log of e to the 0.06t. And again, that lets me move the 0.06t out in front, the natural log of e. And the reason we use natural log is because the natural log of e is 1. And that's going to disappear on us. So now we just have 0.06t is equal to natural log of 2.5. We'll divide out the 0.06. And once you've done several of these, you'll see that there's a definitely rhythm or pattern to it. So our final answer is going to be whatever the natural log of 2.5 divided by 0.06 is. So we'll head to our calculators. Take the natural log of 2.5 again. Watch out if it puts a parenthesis there. Make sure you close that parenthesis before you divide by 0.06. And what you should get is 15.3, and that would be in years. So you should get 15.3 years out of it. So if we invest at 6% compounded continuously, it'll take 15 years for a 10,000 to grow to 25,000. So it takes a while. So in example 5, the problem says John will require 3,000 in 6 months to pay off a loan that has no prepayment privileges. A lot of times when you pay off a loan early, you don't have to pay the extra interest. This one doesn't let you do that. You have to pay the interest no matter what. If he has 3,000 now, how much should he save in an account paying 3% compounded monthly? So in 6 months, he'll have exactly 3,000. In other words, he's got 3,000 now, and he can't pay off the loan now. So he wants to take some of that, not use it, and still invest the rest of it to get 3,000 in 6 months is what they're asking us. So because we see that compounded monthly, that tells me n is equal to 12. It also tells me to use the compound interest versus continuous interest. So there's our formula. We know that we need 3,000 at the end of time. So A is 3,000. We're trying to figure out P. P is our unknown. We do know our interest rate. It comes out to be 3%. We already know n is 12. And 6 months is a half a year. So we'll use that as 0.5. So again, time has to be in years, which is really why we're doing this example. So plugging that in, we've got 3,000 is equal to P times 1 plus 0.03 divided by 5 raised to the 5 times, sorry, I'm not doing that right, divided by 12. What happens when I write stuff in 2 different spots than I'm used to. So n is 12, so it's 0.03 divided by 12. And then we're going to raise that to the 12 times 0.5 for the years. So there we go. Okay, so when it's all said and done, we're just going to divide this stuff out. So P is going to be equal to that initial $3,000 that we knew we need at the end, divided by the quantity 1 plus 0.03 divided by 12 to the 12 times 0.5. And just to make sure we're all plugging it in correctly, I'm going to go figure out what the denominator is. For those of you that are not using a graphic calculator, just to make sure you're on the right track. So I'm taking 0.03, I'm going to divide it by 12. And that gives me 0.0025. I'll add the one, so now I have 1.0025, and I'm going to raise it up there to the 6th power, half of 12 is 6. So to the 6th power gives me a really weird looking decimal, but it's 1.015094063. Okay, now that number is sitting there on my calculator. So what I'm going to do is I'm going to take 3,000. I did not hit enter, and I'm going to divide by that answer. So second answer, and I end up with P equal to $2,955.39. So basically, if he knows he needs 3,000 in, he's got 3,000 now. He's going to deposit $2,955.39 into an account, and then in 6 months he'll have the 3,000 that he needs again. So in other words, he can go spend about $45 of that $3,000. He can go gas in his tank, right? So in example 6, Kelly had 10,000 to invest and wants to have 25,000 in the account in 10 years for her daughter's college education fund. Woohoo, Kelly! If the account pays interest compounded continuously, notice how I go looking for that word first. What interest rate is required? So continuously tells us to use A equals PEBRT. But this time we're looking for the interest rate. So the interest rate is the unknown. Well, we know the amount of in is the 25,000. That's how much she wants for her daughter. The principal we have now is $10,000, and we know that it's going to take 10 years. So in 10 years, what kind of interest rate do we need in order to reach that amount? So we'll plug into our formula. It's going to be 25,000 equals 10,000 e to the point. Oh, we don't know the interest rate, so the r is unknown times 10. So now we need to go solve for r. Last time we solved for t, this time we're solving for r. We can go ahead and divide out that 10,000. So again, isolate the base. It makes the log process much easier. This is again 2.5, works nicely in terms of numbers. That's equal to e to the 10r. Because we're using a base of e, the only way to bring the exponent down is to take a natural log, or to take a log. We use the natural log because we're using an e. So I end up with the ln of 2.5 is equal to the ln of e to the 10r. Again, that lets me move the 10r out in front. I have the natural log of the e, which is 1. And we'll divide out the 10. So the interest rate tells us that it's going to be natural log of 2.5 divided by 10, and that comes out to be 0.0916. That'd be 9.16% interest. So if she can find 9.16% interest in 10 years, she'll have her $25,000 she wants. And that wraps up part 2. One more part to go.